talk about relationships in math, we usually use our coordinate system to describe our relationship, or what we call relations. All right, in our coordinate system, it's forming an intersection of two number lines. And if you remember from before, our two number lines that intersect we call the x and the y-axis. Remember the x-axis runs horizontally and the y-axis runs vertically. Okay? And the point where they meet, where they intersect, we call that, well, at that point it's at what, 0, 0? We call that point the origin. So if I ever say the origin, I'm talking about basically the center of my coordinate plane at 0, 0. Okay? And if you remember this 0, 0 right here, remember the x always comes first and then the y, right? It's x and then y. We call that an ordered pair. Because it's ordered, right? X comes first, then y, and a pair of numbers, x and then y. So for example, if I was going to graph -4, 2, I would go -4 in the x direction. So I always go from 0, 0, 0, the origin. 1, 2, 3, 4, -4, and up to +2 in the y direction. That would be my point, -4, 2. Okay, there's some review there from what we've done before, some terms. So we just talked about this ordered pair. I'm going to write 3 ordered pairs down. That we're going to use here. So 1, 2. Let's use -2, 4, and 0, -3. So I'm going to use those. Because we're going to display our ordered pair in different ways. So a relation is just a set of ordered pairs. And what it'll do is, for a relation, it'll put a little curly bracket here, and it'll mark off the ordered pairs. So a relation is just a set of ordered pairs. Right? And it'll put those little curly brackets to show where your relation's at. Okay, and there's 3 ways I can show this. Well, one way I can show it is just by putting the ordered pairs. My other 3 ways are graphs, tables, and mappings. Okay, graphs we're familiar with. That's what we talked about up front. We'll put it on a coordinate plane, right? Our graph right here. We just graph the points. Sometimes you put a line through it depending on what we're trying to show, but in this case, just graph them. We could write a table, an XY table, right? A lot of times we just do that. We put our X and then our Y, and we list, the ordered pairs. 1, 2, -2, 4, 0, 3. We also have mappings, and we'll talk about domain and range in a second. But mapping is just shows the x goes with what y value, where it gets mapped onto. Okay, we're going to talk about that in a sec. So those are the 3 different ways we can display our relations. So a mapping. It illustrates how each element in the domain is paired in the range. Well, the domains, those are really just our x values. And the range is always our y values. So domain, x values, range, y values. And if we look, you notice how the -2 and the -1 are both going to 4? Well, that just says in this relation, I have an ordered pair of -2, 4. I also have an ordered pair of -1, 4. Okay, it just shows how it gets mapped. And then my other points would be 0, 6, because 0 goes to 6, and then 1, 8, and 2, 8. Those would be my 5 ordered pairs there. Okay, so I don't need to put multiple 8s and multiple 4s here. I can just put arrows going to the same number if that's the case. Okay, so that's a mapping. Remember, domain is our x values and range is our y values. So if it wants you to state the domain, tell it what the x values are. If it wants you to state the range, say what the y values are. So for example here, it says express, okay, that relation, as a table, a graph, a mapping, then determine the range, or the domain and range of the relation. Well, let's start off, let's do a table. Okay, so I'm going to make my table, my x and y table. X, y. Well, I got 4, 3, -2, -1, 2, -4, 0, -4. Pretty straightforward, right? Just got to draw the table. Now I can graph all of those. Remember, I always start at the origin. And 4, 3. So my first point, 4, 3. So I'm going right 4 and up 3, right? X value always first, so that's 4, 3. I'm just going to label it on here so you can see 4, 3. That's an ugly looking 3. -2, -1. So -2, left 2, down 1. Always go from the origin, right? -2, -1. And then I have 2, -4. So right 2, down 4. So 2, 4, 2, -4 there. And lastly, 0, -4. So 0, I didn't move left or right, and I'm going down 4. 0, negative 4. So there's graphed. And then lastly, do a mapping. Okay, do a mapping. So I got to start with one bubble here and another bubble. Remember the x's go on the left, y's on the right. So I just put my x's down. Well, I have 4, negative 2, 2, 0. They don't really have to be in order if you don't want. And then my y's, 3, negative 1, negative 4, and negative 4. So I don't need to write the negative 4 twice. And then you just go, x goes with what? Y. Well, 4 goes with 3, negative 2 goes with negative 1, 2 goes with negative 4, and 0 goes with negative 4. So I just draw an arrow to each of those. And then it says, state the domain and range. Well, the domain are just your x values, so go ahead and write domain above that, part of your mapping. And range are your y values, so this would be my range, 3, negative 1, and negative 4. There you go. So table, graph, mapping. State your domain and range. Don't forget to do all those. We also have independent and dependent variables when we talk about relations. Well, the key here is one depends on the other. So if you think about it, dependent means the dependent variable depends on the independent. That's how you can tell the difference. The dependent variable depends on the independent. That's how I always think of it. Okay? So let's look at a couple examples. We're going to identify the independent and the dependent. I'm just going to go ahead and write I for independent and D for dependent. So which one depends on the other as I read through this? In warm climates, the average amount of electricity used rises as the daily temperature increases and falls as the daily average temperature decreases. Well, which depends on the other? What are my two things here? If I look, I got electricity used and daily temperature. So does electricity used depend on the temperature, or does the temperature depend on the electricity? Well, if you think about it, the electricity depends on the temperature, doesn't it? Because depending on what the temperature is, that's how much electricity used. So the electricity, I knew how to spell, electricity used, right? That depends on the average temperature. So the average temp would be your independent variable, right? Because the electricity depends on that. So same thing with the other one. Look for which one depends on the other. The number of calories you burn increases as the number of minutes that you walk increases. So basically, the more you walk, the more you burn. So which one depends on the other? Basically, the number of calories depends on how much you walk, doesn't it? So the number of calories burned, or calories burned, depends, right? That one depends, doesn't it, on how much you walk. Minutes you walk, or how much you walk. So you just got to think of which one depends on the other. Calories depends on how much you walk. Well, when I have something graphed, or a relation graphed, how can I describe this? What's happening here? Okay, let's just think about this. It says driving to school. The title's important. I got to read the title. See, time is on the x-axis, so as the further we go right, the more time increases, and the distance. So this means as you go up, the distance is increasing. Okay? So let's think about some things here. If we look at this first part, it's increasing pretty fast, isn't it? So we're driving fast initially, and then it has a little horizontal line right here. What does that mean? As the time is increasing, the distance doesn't move. So we're stopped, aren't we? That's where we're stopped. And we're also stopped right here because the distance is not moving over a period of time. So basically, let's just put this into words however you want. There's a lot of ways to describe this. You could say, you know, the vehicle is stopped for 2 periods of time. In the beginning, the vehicle went a little faster, didn't it? the fastest, I guess you could say. So anything that has something to do with you moved a little faster right away and you stopped. You were stopped at 2 different times. Okay, you could have started from the beginning and talked your way through it, or I just said it was stopped twice and it moved faster at the beginning. Just describe what's occurring there as the time increases. Okay, just tell me what's happening with that relation. All right, so a little bit with your coordinate system.